Alright, so here's a question from the 2017 TMUA paper 1. This is the final question. And let's just get a sketch going. So we'll just draw a random triangle here. Let's try and make that a bit nicer. Alright, that's good enough. So, yeah, we have our triangle PQR here. And we're told side lengths QR is A, RP is A plus D, and PQ is A plus 2D. So the side lengths are an arithmetic progression. This actually is completely off scale because this should be a shortest length than this, but it will do for now. And we're asked to find the full range of degrees or possible angle measurements for the angle PRQ, which is this angle here. So, and we also have the condition 3D is less than 2A. So that will probably be useful. We'll have to come back to that later. But first, let's make a start by just using the cosine rule to link together these three sides and this angle. So remember that the cosine rule is a squared equals b squared plus c squared minus 2bc cos theta, where these are the sides. So we have a over here, theta there, and bc either side of theta. So we can apply the cosine rule on this triangle here to get ourselves, actually, let's rearrange this for theta first. So I'll just move the 2bc to the left side and move the a squared to the right side. Then I'll divide by 2bc and take arc cos of both sides as well. That will give us b squared plus c squared minus a squared over 2bc. Okay, now we can substitute in our values. So our formula for theta is going to be b squared and c squared, which are just a and a plus d. So that's a plus d squared plus a squared, and a squared is a plus 2d. I know it's a bit confusing with the capital and lowercase a, but hopefully it makes sense on the paper. And over 2bc, that's just 2a plus d. Okay, there we go. So we have a formula for theta in terms of a and d. Now let's try and simplify this formula a little bit and see what we can deduce. So I'm going to expand all these terms. Minus this. And we'll just leave the denominator as it is because we're trying to cancel things down. So you can see these a squareds cancel out, and then we're left with a squared minus 2ad minus 3d squared over 2a plus d. And we can actually factorize this into a minus 3d, a plus d, which is good because now these a's plus d's cancel out. No chance of them being 0 because both numbers are positive. Here. Okay, so here's our new formula, and we will just factor out the 1/2 and write it as a sum. So that's going to be a over a, which is 1, minus 3d over a. Okay, now this is where our constraints come into play. So we already know 3d is less than 2a, and we will rearrange that for a. So we know a has to be less than 3 over 2d, right? Just rearranging this. So we have a upper bound for a. And how do we get our lower bound? Well, we need to remember the triangle inequality. So if we have any triangle, or any set of points, I should say. Let me just try to reconnect this pencil. Okay. Right, so if we have any set of points and we just draw lines between them, we can give each of these lines a length. Let's just say we have A, B, C, where they're in descending order, so A is less than B is less than C. And in order to form a valid triangle, we need the sum of the two shorter sides must be greater than the longer side. And this makes sense, right? If you had the longer side C over here, if the sum of these two sides were shorter than it, then they wouldn't be able to connect, so you wouldn't be able to form a triangle. So they need to at least touch, and you can see the limiting case when they are equal, that's just going to be a straight line. So we need a tiny bit more than that, which is why it's not a inclusive greater than, it's just a strict greater than. A tiny bit more, and that will let them form a triangle like that. So using this inequality here, since all A and D are positive, we know that A and A plus D are the two shorter sides, and A plus 2D is the longer side. So then we can say A plus D has to be greater than A plus 2D. And then doing a bit of rearranging on this, we'll get A is greater than D. So there's our lower bound. Combining these both, we're going to get A is between D and 3 over 2D. And now what we can do is substitute these into our formula over here. 1 minus 3D over A. Now, it's important to know that since this is a reciprocal function, it's actually always going to be decreasing, so we don't have to worry about if it was a quadratic, it might go up and down, which means the cos inverse would get messed up because there might be, we can't just look at the endpoints, right? There might be a value in the middle where the angle, the maximum range gets extended. So it's lucky that this is reciprocal, similar to a linear function, because now we can just look at the endpoints to find the maximum range of the angle. So let's substitute in A as D. Also note that cos is a descending function in the range we're interested in. So the lower value of A should give us, well, it's going to give us the higher value of this, which is going to give us the lower value of this. So it's going to give us a higher value of theta. But we don't have to worry about that too much. Let's just substitute in the values and see what we get. So 1 minus 3D over D, that's going to be, the D's cancel out. 1/2 multiplied by minus 2, which is arc cos of minus 1, and that is just 180 degrees. Now let's substitute A is 3 over 2D, so that tells us theta 2 is going to be 1/2 1 minus, well, this will be 3D multiplied by 2 over 3D, so those cancel out, and we're left with 1/2 multiplied by minus 1, or minus 1/2, and, or you can use the identity, that's equal to 180 minus cos inverse 1/2, or you could just know that that is equivalent to 120. So there we have it. We can see that theta must range between 120 degrees and 180 degrees. Ultimately, that would give us answer E. Thanks for watching, and see you guys in a future video.